Hello, and warm welcome to Consolis Environmental Sustainability Week, where a full week is dedicated to inspiration and knowledge sharing about environmental sustainability. My name is Tomas.plauska, and I am Sustainability Manager at Consolis Group. I also will be the host and moderator of this Consolis event, which will have been, which we are organizing already for the last 4 years. This year, Environmental Sustainability Week is dedicated to showcasing the progress we as a group are making towards net zero precast concrete and green spine line. At Consolis, we are committed to leading the sustainable transformation of our industry, and this week serves as a crucial milestone for showing our direction and progress. Our colleagues are invited to participate in seminars and panel discussions featuring both internal and external speakers and experts. And this morning we are having a keynote with an external speaker, Ida Karlsson, who is a PhD student at Chalmers University of Technology and also a work task manager of Mistra Carbon Exit research program. She will be sharing the results and the amazing climate wins from the recent Stockholm apartment house project. Hello, Ida.
Hello, great to be here.
It's great to have you here during the Consolis Environmental Sustainability Week. So please also meet Henrik Vinell, who is a business developer at Consolis Strängbetong. Today, Henrik will discuss the practical aspects of this project, including the concrete and structural optimizations that were done by Consolis Strängbetong. Hello, Henrik.
Hello, Thomas.
Ida and Henrik, you will be addressing the following question. Can construction be both climate friendly and cost efficient? I'm very curious to hear your insights. Ida, are you ready to take our virtual stage?
I am. Thank you very much. Hello, everyone. I am honored to be here and get to talk about this amazing project, which I have had the privilege of following for about 1.5 years. It's a case study of the Hestur building project, which is an apartment building in Kista, north of Stockholm. And this has been an early collaboration project between the property developer and owner, Byggvesta, the contractor of the AF Group, and the subcontractor and precast provider, Consolis Strängbetong. And my entry into this project was exactly this question: can future construction be both climate smart and profitable? And that is what I will share for you today. But to start with, some info about the actual project. This is an apartment project containing 150 rental apartments and 70 student apartments. And there are apartments ranging from 1 to 4 rooms with a kitchen and 3 premises at the bottom level. It has a basement level with a garage. And the first occupancy is actually tomorrow, so it's very close. So it's just a very, very recent project. And it will be owned by a joint venture company between Byggvesta, the property developer and owner, and another property owner, Bonnier. So then to the results of the Hestur case study. Were we able to show that this is possible? And yes, we did, happily. So we actually were able to demonstrate a climate footprint for this project, including the material and the transports of the material, as well as the installation of the materials for this construction, with a climate footprint of 270 kilos carbon dioxide equivalent per square meters of gross floor area, which is the most common metric used for this. And this is actually a reduction of around 36% compared to reference or similar buildings that are being constructed in Sweden. But also most interesting, compared to the original setup of this building, the optimizations and the measures taken were able to reduce the cost of the structure by 5%. And I will go a bit more now into detail. What happened? How was this done? And it was a climate improvement in several steps. So if we start from this reference that I talked about, so in Sweden, there's been a large study looking at all types of buildings and taking in reference levels for prefabricated concrete frame, multifamily buildings, and looking at what is the average carbon footprint of these. And compared to that, we see that already with some measures, with the very optimized original building design that was resource efficient, combined with conscious choices in the products, for example, recycled reinforcement steel in the structural frame, it was already possible to reduce the carbon footprint by 25%. But then a lot of this collaborative work started. And with the involvement of subcontractors, the outer walls were changed to battery poured walls, meaning that they were poured in a flat horizontal structure, which meant that the cement content could be lowered. And as well, there was an reduction in thickness of the interior walls by structural optimizations, going from 220 millimeters to 200 millimeters. And the similar for the hollow core flooring, also being reduced from 220 to 200 millimeters. And in addition to these optimizations, there was this optimization in the concrete recipes with cement substitution to steel slag in most of the prefab elements, as well as in the foundation in the in situ cast concrete. But the collaboration and the work and the measures didn't stop there. There was a deeper cooperation leading to there was a possibility to further reduce the thickness of the inner walls down to 180 millimeters. And also some of the inner walls were changed to lightweight walls rather than concrete walls. As well, some of the inner walls were also cast with a microsilica as an additive, with also made it possible to reduce the cement content even further. And with all of these measures, it was possible to reduce the overall carbon footprint by 36%. So how was this done? Well, then to summarize, it was the structural optimization leading to thinner elements that were building elements per building element. And optimized concrete recipes for each of the precast elements. And as well as cement clinker substitution. And this combined with conscious product choices, such as the recycled steel, were able to get this reduction. So the outcome, as I said, more than third reduction in carbon footprint. But if we look only at the prefabricated elements and compare them to the reference projects, we actually see that the carbon footprint was halved. So the importance of Consolis Strängbetong, it can really be seen there. But we did not only look at the carbon footprint per area, but we also brought in another metric in this research, and that's looking at the carbon footprint per resident that the building is designed for. And if we look here and compare the sector references you see in the bottom right here, you can see that the sector reference for multifamily houses were around 18,000 kilo square meters per person in Sweden. But this Hestur project managed to more than half this, down to 8,400 kilo carbon dioxide per person. And just to understand what does that actually mean, it's in perspective, it's around 2.5 times a flight from Sweden to Thailand and back. So that's as much as the Hestur project was emitted, but also about as much as it was saved compared to the reference. And if we look at then more into some of the details here, as I said, it includes both the materials and the transport and the actual construction process. And if we compare this, we see with the sector reference, we see, of course, that the materials are reduced a lot. But not only that, we're also able to reduce the emissions from the transports. And that's partly by using as local suppliers as possible. So the concrete fabricated elements were produced in a factory quite close by. And also it was able to, the transports were using biodiesel rather than fossil fuels in the transports. But we see too that the materials have the biggest impact. And if we look at the share of climate impact and looking at what are the different building elements, we see that there are, it really is the frame, the structural frame that is the main part of the climate footprint. The internal walls combined with the flooring, foundation, basement, and the external walls are about 3/4, 3/4 of the, or 75% of the total climate impact. We also looked here at the material consumption. As we can see, a sector reference of these multifamily houses have a material footprint of about 1,500 kilos per square meters. And the resource efficient design combined with the optimizations made it possible to reduce this down to around 1,000 kilos per square meters. So it was able to cut 1/3 of the material consumption. And that meant that even compared to the original design and optimizations that were taken, it was possible to reduce also the cost of the materials for the structural frame with 5%. I will finish here off with some 3 pieces of advice for all of those of you out there who would like to also pursue these types of optimizations and hopefully get same or even better results. And that's to focus on minimizing the material consumption at all stages, as it goes hand in hand with both climate and the economy. And to start early in the process. Resource efficient design creates a good starting point. And also to set collaborative arrangements early in the process, to engage closely all throughout the project, and include early on an agreement on the joint goals for the project. What are you aiming for? And also ensure that you have requirements in contracts going down the supply chains, also with subcontractors and material providers. And with that, I will wrap up and give the word back to you, Thomas.
Thank you, Ida. It was really great to learn that costs and CO2 emission reductions can go hand in hand, particularly when having a good collaboration, and second, when involved early in the project. Now I would like to invite Henrik to walk us through the project execution. So what has been done by Consolis Strängbetong on the design optimization related both to structure and the concrete.
Thank you so much, Thomas. Actually, I would like to start with not the what's, but how we did it, because I think it's one of the most important things that is how we cooperate and work together. And I think that in this particular project, that's key. And so I've written down just 3 bullet points here that I think was important for this project. And going back through my emails, I realized that 2 years ago, we started to talk about the CO2 hunt. And this is not like a competition, but the owner and developer, Big Vesta in this case, they really wanted to improve the climate performance of this building. So we started working together under the heading of the CO2 hunt. And I think that was a very good thing to do because we were all focused on reducing climate. And also, I would like to emphasize again the good cooperation between the involved parties. The way I see it is that normally we have a chain of command where an owner wants a building done, hires a general contractor who in turn hires maybe subcontracts, etc. And that is of course being done in this project as well. But we had a really good cooperation. And then again, it needs to be said many, many times over, start really early in the process and work together. And when you have the 2 first bullet points, we also create somewhat of a dare culture. And of course, many of us, we are technicians and engineers, and we want to do the right thing, because every building must fulfill its demands and all the standards and comply with a lot of things. But it's easy when you work together to establish this kind of dare culture. And I think it will take you those extra steps, like Ida was saying, that how we were able to reduce the walls in different stages. So we didn't reach the end result at first go. So we had to work with it a bit. So that's basically those things that I think are really important and was important for this project. Next, please. So then again, what did we really do? And in other wording maybe than Ida is that we want to, of course, find out the right solution for this building or this house. And normally I would say it ends up in using less materials. And also, like in this case, we use different materials than concrete. Um, Sometimes we also shift to concrete, but anyway, optimization is very important. And in this case, as you can see, we were able to reduce all the floors, and the flooring was of course made of hollow cores, which are to start off with already a very optimized product, but we were able to reduce a thinner and also lighter product. It's actually 50 kilos lighter per square meter. And I think the key to that is also that, which is not being said earlier, that we have a raised floor solution in this building with not structural topping on the hollow cores directly. We have a layer of insulation, then on the top of that some kind of structural topping, and then you have the flooring, and that also takes care of the sound insulation in a very good way. This building isn't Class A in Swedish terms, so it's not registered. I think in Class A, which is the highest sound insulation class, and very few buildings are. But it has good sound insulation, and that was also being calculated and taken care of in the project. And Ida has also described that about the walls, and in total, we were able to reduce quite a lot of mass in this project. And then the second simple, easy to say though, bullet point is that appropriate demands for concrete. Because we have to really think about, do we have the appropriate exposure and strength classes? And sometimes I think it's easy to make fewer drawings and make everything very simple and alike, because you have the power of making several identical elements. But I think we have to rethink and really scrutinize what kind of exposure classes and strength classes are needed and where. And when that is done, then you can actually start working with the concrete receipts. And in this project, we did this, of course. And for the slabs, the hollow core slabs, we were using receipts based on SEM2, SEM2A with lime filler, and in combination with secondary cementitious material like slag, GGBS. But actually, all the walls, they were casted with also with traditional SEM2 cement and with lime filler. And in some cases, in some types of some of the walls, internal wall, non-load bearing walls, we were also using bio ash in combination with SEM2. And in the end, what I believe we did is actually that we were able to contribute to more affordable apartments, because we were able to do a lot of changes, keeping the costs down, and which is also, in the end, is good for the tenants that are actually soon to move into the apartments. Thank you so much. Back to you, Thomas.
Thank you, Henrik. Thank you. I truly think this is a great example demonstrating Consolis Strängbetong's capability, how through collaboration with your partners and customers, you were able to contribute to this significant CO2 emission reduction. So now, Henrik and Ida, let's look if there are any questions from our audience. Yes, and we have some questions. There is one from Petri from Finland. I think that maybe would be for Ida. Have you collaborated have you calculated emissions for 50 years life cycle per square meter? He refers to the 207 kilogram CO2 equivalent per square meter floor area.
Yeah, I just did a calculation because he added, yeah, it's just divided by 50, and then you get 4.14 kilos carbon dioxide per square meter in a year. And I also double checked how does it compare to, we don't really use that in Sweden, but I know it's used a lot in Denmark. And it compares very well to the multifamily buildings also in Denmark.
Thank you. Thank you, Dan. And then another question to Henrik. If you were actually to redo this project, is there anything you would do differently to further reduce CO2 emissions, or have you already achieved the maximum possible reduction?
No, not by far. My estimate is that if we would redo exactly the same building, not saying we would, but I mean, exactly if we were to redo exactly the same building, my guesstimate is that we will reduce the emissions by another 10 to 20% if we built it today one more time. And that has to do with we have improved also the receipts, concrete receipts, and further we would use a totally different, less emitting cost in situ concrete. And we would also optimize using electricity or gas transport today. And I think that the total of that is between 10 to 20% improvement still. So
Thank you, Henrik. That's great. So you learn from the projects and you move on and you basically improve even further. That's great to hear. But also, Ida, it was really interesting to see you actually comparing CO2 emissions per resident alongside the CO2 emissions per square meter of building floor area. This residence based comparison is quite unique. Actually, it's not so commonly used. So what insights have you gained from evaluating these different KPIs?
I think this is something that has been discussed, or that I've discussed already during my entire research, really. How can we combine different metrics in order to ensure that we don't lose sight of different parameters? Because if we only focus on carbon dioxide per square meters, it's quite easy just to extend the number of square meters with no real function in order to reduce the carbon dioxide per footprint per square meters. And that's why it's also important to look at what does it mean per person, and the same thing with material intensity, so that you can compare it and look what is actually the function that we were delivering. We're delivering housing. How can we do that in the most optimized manner? So I'm really encouraged by that is actually a metric that is now being used in this reference case studies, for example, but also something that we can bring forward and start using. So it's something that I am arguing for in a lot of different arenas for both property developers and owners and others to start using, so that we focus on resource efficiency. We also focusing on the function that we're delivering.
Thank you, Dan. So we are coming to a close. So I would like to thank you, Ida and Henrik, for joining this session and your actually insights about this very interesting project in Stockholm, Sweden. Thanks for the ones that were listening in and for really engaged audience. And thank you for your questions and comments. So thanks again for listening in. Take care, everyone, and bye-bye for now.
thank you so much.
Thank you. Bye-bye.